Welcome to solverfy.
So first we can rewrite this in standard form. We see that here we want to maximize z is equal to 3x1 plus 2x2, and we are subject to our constraints. x1 plus x2 has to be less than or equal to 10. 3x1 plus x2 has to be less than or equal to 24. And x1 plus 2x2 has to be less than or equal to 16. We also know that x1 and x2 have to be greater than 0. Now we can use our Excel to find our solution. We're going to get that x1 is equal to 4, x2 is equal to 6, and z is equal to 18. Now let's change the objective function coefficient for x1 from 3 to 5. Our optimal solution does change when our coefficient from x1 changes. We are going to see that we are going to get z is equal to 5x1 plus 2x2, and we're going to get our new values. x1 is equal to 6, x2 is equal to 4, and z is equal to 34. Next, let's change our objective function coefficient for x squared from 2 to 4, keeping the coefficient for x1 at 3. So now we're going to have z is equal to 3x1 plus 4x squared. We're going to find our new values are 2, 7, and 31. So again, we see that our values do change when our x squared changes. Our shadow prices can be found using our Excel solver. Our shadow price for constraint 1 is going to be $1. For constraint 2 is also going to be $2. And for constraint 3 is going to be 0. From these, we can conclude that increasing the right-hand side of constraint 2 will increase the optimal value of the objective function, while changes to the right-hand side of constraint 3 will not affect it. Our binding constraints are those that are satisfied with equality. In this case, we see that x1 plus x2 is equal to 10, and 3x1 plus x2 is equal to 24. And then our non-binding constraint is going to be that x1 plus 2x2 has to be less than or equal to 16, since it directly affects our solution.